Good morning, good afternoon, good evening, depending where you're joining us from. We are here again to solve the Wizer CTF number 13. This is part of Wizer Secure Code Training. And basically, the idea is that it's a retired challenge. So you can see on the right, there's everybody that was able to solve it when it was live. It still is live, but it's not a challenge that you can win anything for. However, you can still try to solve it on your own. But what we are going to do today is basically show you the solution. If you want to learn how to basically solve these CTFs, it's a very interesting one. Like all of our CTFs, this comes from real life examples that are happening out there in the wild. So with that said, I'll let Itzik explain what the challenge is and how to solve it. Itzik, the floor is yours.
Thank you, Gabi. Yeah. So what we have here is a typical part of an app, maybe a CRM app that actually saves and retrieves the company logo, so they can appear on the left, on the right. And what we have here is three endpoints. The first endpoint, very typical, is get logo. The logo is saved per company based on company ID on a specific folder. It's a file, and the name is the company ID. So just to get the company logo, you provide a company ID. It's being validated, and then it's retrieved as data and returned as data. Can present it as a logo for your CRM.
Can I stop you for a second?
Sure.
Let's start with what the challenge is, and then let's redo everything, okay? Because I want people to know what is the challenge? Like, what are we supposed to do here?
Okay, so the challenge is asking the users to get the CRM users from the internal network API. And we'll show that there's an API that shouldn't be accessible that allows that. But that's the challenge, to get the CRM users from the internal network.
There is a list somewhere of internal users, and we as the attackers, we want to basically somehow hack this code in order to retrieve all the users from the internal network.
Yes, the CRM users, exactly. Okay, so the first endpoint, we'll do it again. First endpoint is get company logo, saved as a file based on company ID. That's the file name. So when you provide the company ID, when you send it to the request here, it's retrieved, validated, and then the file is being read from a folder where the company logos are saved based on the company ID. That's the name of the file. So that's the get, and it's retrieving the data as the response.
Simple.
The other endpoint, the second endpoint, is set company logo. Again, fairly simple. Since we know what the get does, it does exactly the same. It saves a file with the company name. So the company ID is being fetched. The image URL is being validated. Okay, so there's a validate image URL, which is a function here that checks that we're actually providing an HTTP request, and it's actually a valid URL. And if it's a valid URL and everything is great, we are validating the URL. So you get a company ID and an image URL. And what it actually does, if it's actually valid, then it goes in here and writes a file with the name of, refreshed. So it writes a file with the image into the company ID file. So that's going to be the name of the file. That's actually the file itself. So the way to do that, we fetch the image URL and then save it as a file on the local drive. Make sense so far?
Yeah, simple. So 2 endpoints so far. One for uploading your logo and another one for fetching your logo. So far,
exactly.
So good.
Now, there's another endpoint here. It's unrelated maybe, but it does, it gets the CRM users, okay? But you can notice that it's fairly simple. There's no authentication at all here. And why did the developer think it's okay? Because they exposed it only within the network. So it's internal network only, port 4001. Only if you're in the network, you can access the local host and get actually access to this API. So it's not exposed externally. That's it. However, the challenge, as we said before, is to be able to actually get to that API, even though it's not exposed externally.
Cool. So show us how you do that. How do you access an internal function that is not exposed externally?
Right. So the trick is SSRF.
Okay.
So how do we do it? Okay, and we'll explain what SSRF is. It's Server Side Request Forgery, but let's start with explaining. We need to first prepare. So we need to set a company logo, which actually has malicious, unintended request. In this case, the company name, whatever, UUID 4, version 4, valid, key we just provided. And then instead of the image URL, we provide a request to the local host port 4001 and request the CRM users. So we're actually creating an image that is actual, or a logo that is actually not an image, but it's performing a request since we're using the fetch method. Okay, so let's do that. Create that folder. We got OK, so it means that the folder is saved. And now we can exploit it. How do we exploit it? We just go in here and okay, disappeared for some reason. Oh, sorry, that's the solution. We go in here, we go to get company logo and the ID that we just saved. We hit send, and instead of a logo data, just supposed to be binary PDF or a PNG, we get the actual CRM users here.
Cool. So can you go back to the code for a second?
Sure.
And scroll down to the so basically what we're seeing here, so this is okay, this is just now I see this. It's not an API that is only internal. This is basically the app listening to a specific port, but we are making sure that it only accepts local host. So we didn't, if I understand correctly, we didn't get access to an internal API. We basically got access to that listening function.
Yeah, and that's an internal API because what it means is that it's accessible only locally. It's accessible only from within the network. This is the fact that we put localhost here means that it's listening on port 4001, and 4001 is not listening externally.
But if there was, the reason I'm asking this, if there was another app in the network listening on localhost, unrelated to this specific app, as long as those two apps are running in the same network, will I also be able to access other resources in the network?
Yeah, you can have multiple computers or multiple servers listening on the same port.
Okay, so this is outside, this can be outside the context of this app. If there's another server or another app running internally, I can use this code to access a whole different app that is limited to internal network, as long as they both see each other.
Yes, this was, this is an illustration that shows in one file
everything.
Two things that could have been different servers even.
Exactly.
Illustrating the idea that you can take advantage of requests that are being made internally to kind of like create a forgery request, on the server and get access to things that are not available externally.
Exactly. So you may be like a system admin and you configured your server, something else like a SQL server, whatever it is, and it's meant to only service internal users. You did very good in like protecting it and all of that. But then this other app, because it wasn't written in a secure way, basically exposed the whole network just through that single API. This just shows how dangerous something like this can be in exposing your whole network.
Absolutely. What is common usage of SSRF, for example, is to get configuration from AWS and other things. So there is a port that you can access to get, only the app can do that. People from the outside world can't do that. But if they have SSRF capabilities, they can actually get to that configuration, get very sensitive keys and access to things that are not supposed to be exposed. Same way.
Which is why, sometimes they say change the default ports, because if you're using all the default ports, then people know what to look for. So because you
Yeah.
may say, hey, how would they know 4001?
So with that being said, I'd be very careful in obscuring here because it's
Yeah.
not security. The best way, again, and maybe that's going down into takeaways, and we can start with that takeaway, is the most severe issue here in this app is that we haven't protected the CRM user API because we assume that if it's in the internal network and it's not exposed externally, only my people can access it, and I'm okay with that, and that's great. We should always assume that we have access to our internal network and resources, and we should never keep it open and unprotected. So the CRM users, the best solution here would have been to create authentication that requires some way of identifying yourself before you retrieve CRM users that could be sensitive, even if it's an internal network.
So basically treat it like any other app that is internal. Make sure that don't just assume that, okay, people can't access it because they're from outside.
Exactly.
And I'm okay with, make sure that you have this authentication and authorization for anything that is listening.
Exactly. And then there's another takeaway here. It's for the SSRF itself. Like, this is an outcome of the SSRF if you're not protected on the backend. But there's also for the coder, okay, of the app, to prevent SSRF, you just completely avoid requesting URLs that is controlled by user input. So if a user input is inputted, it's very, very hard. Believe me, it's not easy. And there's another challenge that does that later on. We'll talk about it when we get there. But it's very, very hard to sanitize and prevent SSRF. There are so many other ways and so many different ways to do the same thing and bypass. So not even sanitization is good here. My recommendation would be completely avoid requests that are done on something that is not, well set. If it's your server, that's great. You can do requests. If it's user input, make sure that it's only maybe a variable and you can't go outside. But you just need to be very, very careful not making requests that have user input involvement in them.
Yeah, because you never know. You can't think of everything, right? And
Exactly.
even if you do this, my guess is there are libraries for that, and because this is such a big challenge to sanitization is hard enough. I would say URL is probably even harder.
Yeah, and it's not only URL, because the other challenge that I'm talking about is actually you have a valid URL that actually is great, and it's not localhost, right? And we were able to sanitize that, but there are other ways to do it. So that's why I'm saying sanitization is not a very good solution here at all. You just avoid requests, and that's the best way to kind of block SSRF altogether.
So where do the developers where does this start? This understanding, is it at the architecture level? Is whoever architected and designed the app before we started to code, was that when we were supposed to sort of bring this up, or every developer just needs to know this?
That's a great question. So a little bit of all, right? Of both, right? So in the design, if the requirement said specifically that you can have an image fetched from a URL, that's where you need to be very careful defining that and making sure that SSRF is not possible. So that's the security shift left, is on design, you should say there shouldn't be an option for requests in the local network, for example. Okay? So that should be a requirement. So that's when it shifts left. But when the developer gets it, they might think, okay, we can provide a file, but they can actually expand the requirements. And developers love doing that. It's like, oh, I give you another option. You don't have to upload a file. You can also upload it as a URL. Wherever you put it, I'm okay with it. I'm going to fetch the file. And that is where developers maybe take and expand the scope. So it's a little bit of both. You need to be careful that this doesn't make it to your app. The better approach is to start on design, but it's always the developer, responsibility to make sure that it didn't make it there.
Okay. What about QA? Do you think they should be? I know that I'm expanding here a little bit, but is it expected from QA to test this type of stuff?
Yeah. Yes, absolutely. QAs should have the ability to check for common vulnerabilities. SSRF, when QAs really understand the functionality of the application, should be one of the things they check. So if they know that from a functionality perspective, the URL can be hosted somewhere and fetched, then they can assume, even without looking at the code, they can assume that there could be issues with SSRF. So it's definitely a valid point that QAs should have a testing script that validates that requests to fetch icons or whatever, the logos and whatever, right, do not provide access to SSRF.
And this is why we suggest, so this sort of ties back into the secure code training. So we have a module that is more limited, doesn't go in very deep, but explains the concepts for QA teams, because I truly think that if you can involve some really basic QA, security QA testing, the benefit is huge. You're going to be saving so much on resolving things later and pen testing and all of those things, just by having the QA at least understand some of the basic concepts and do simple tests and have that something that is just continuous. So because there's so many points of failure, that is very, very hard to find unless everyone in the team, starting from design, developers, and QA, they all sort of sync together. So that sort of is the tips for today. Itzik, any last tips, anything you want to say before we finish this stream today?
No, I would just mention that we have active challenges twice a month. We have active challenges. The latest one is number 37, available starting last Thursday, and is available here, waiting for you guys to solve. It's a fairly easy one, but a nice one. I really recommend you try it. And maybe last words here. We have a tournament going on that is starting on Sunday. So if you haven't registered yet, I truly recommend go to sam.wizerctf.com, save your spot there and register, and we'll be happy to play with you on Sunday the 27th at 10 a.m. Eastern. We're launching it.
So it's a CTF Blitz. It's 6 hours, right?
6 hours, exactly.
6 hours, 6 challenges, and there's some cool prizes. I think first place is $600, right? Something like that.
Yeah.
And it's also a reason to brag. So there are some really, really good players. Some of the people on our community are just amazing. Like, it blows my mind how they are able to solve these challenges in 6 hours. Some of them are really, really hard. So feel free to join. We are going to resolve them later. So when the challenge ends, we'll sort of explain them as well, right? Or we do that a week later. I don't remember. Do we do that?
We do that at the end. We at least review them. We're keeping it open for folks to continue to play if they want.
Okay.
But the snapshot of the winners is 6 hours into the game. The game is going to be blocked, and then we're probably going to reopen it for people to.
Okay. So for those of you who want to try out the ongoing CTFs, the ones that you see here, then you can just sign up for Wizer and go into the app, and then you have access to this. Every 2 weeks, we release a new one. There's also a community version, which is what you're seeing right now. It's the wizer-ctf.com. And lastly, there is once a quarter, we do like a big event. That's the sam.wizer-ctf. And that's where you register. And it opens up in this case, on the 27th at 7 a.m. Pacific time. So, see you there. And Itzik, thank you very much. Until next time, thank you. And
thank you.